So this is pretty dense and inflexible, but it becomes very pliable. This is what I did to start the company. So this is the material that goes into our product. It is actually the laboratory. So developing this compound and actually its predecessor compound came from here.
The build process for the ArcoTech stator starts with the bare metal tube. Some tubes are brand new, while others are coming back from service to be relined.
In order for us to make sure that our rubber liner is completely concentric within the tube, we have to measure how bent the stator is, and so we'll actually put it on here and measure to the thousandths of an inch how bent we are.
After visual inspection and measurements, the tube goes through a thorough cleaning and rinse.
In order for us to get the rubber to bond to the metal, it's very cleanliness intensive.
To achieve the next level of cleanliness, tubes go through an automated grit blast to prep the bare metal surface.
A lance will traverse through the inside, essentially sandblasting, but with a grit media. And that physically cleans the surface. It's a very rough finish, like you would expect from something that's been sandblasted, but it's a much coarser finish than if you've ever seen sandblasted, like body panels for cars. It's much more rough than that. That allows us to have an increase in surface area, but the real reason is just so that we always ensure that it's a clean white metal finish.
After the threads are taped off, the tube is ready for primer and a special coating that ensures the rubber will adhere to the tube.
So the primer application is a lot like an automotive paint sprayer. And so we direct that spray at a specific distance from the tube ID. It's always fixed. And we overlap it depending on whatever size of tube we're working with. It goes all the way to the front. As it goes in, it will blow any amount of dust that's in there, so only air will come out. When it gets to the end, it will begin to extract and spray the adhesive in a rotating, spiraling pattern. That application that you just saw, but the idea is to have a nice, even coating on the inside.
With the interior coats applied, it's time for the tube and mold to go into the ovens along the back wall of the ArcoTech facility.
So what you have here after our prep center is you have the mold assembly station. You have a core oven on the left and you have your tube oven on your right. Both of them have to be heated up to a certain temperature, and that ensures proper injection on the injection machine behind you. We're going to open the ovens and you're going to have your mold on the left side and you're going to have your tube on the right side. We're prepping a mold for insertion. We got to make sure we got enough pipe dope so we don't gall up the threads or damage the threads. We use a seal method with elastomers that seals on the ID so we don't damage customer threads. This guy back there knows when to push so it doesn't run in. So it's not damaging the ID of the tube, it's not damaging our core. So you see the spider coming out. So this whole assembly process ensures that we have a seal on both sides. Now we're injecting with high pressure on the injection machine, so it prevents any kind of elastomer from exiting out of the tube. All the elastomer stays within the tube and around the mold. He's going to tighten that nut, and he's going to pull the whole mold this way inside the tube. As he's tightening over there, he's pulling the whole mold assembly in. Now the process will be to put this plate on and finally cap it off.
The stator assembly is now ready for rubber injection.
So what we're doing is we're going to go ahead and load this. We need to have a lot of hydraulic clamping force. The rubber's going to come out of that nozzle, and so we're going to line it all up and we're going to clamp it. Now we're going to hydraulically force the rubber out of the machine and into the mold. So we control the speed that the rubber moves. If it moves too fast, it can actually start its own vulcanization reaction. So we have to move quickly because time is money, but not too quickly to where it compromises quality. And that's a very delicate balancing act in how we program it. So every single stator mold that we have, right, every model has its own program. Every one of them is optimized for how fast the rubber is allowed to move and under how much pressure it's allowed to move. Because the machine right now is pulling with very large hydraulic cylinders. The rubber is entering in through this cylinder, and it's actually traveling through an extruder, and it's deposited inside of this cylinder back here. There's actually two injection cylinders. One of them is filling with rubber while the other one is actually pushing rubber out.
Even though ArcoTech is all about the latest technology, there are still a few low-tech tools that come in handy.
Sounds very dead. Rubber.
Once the stator is filled with the custom rubber compound, it's time to move over to the vulcanization tanks.
The rubber that you saw in the lab is unvulcanized, right? So it's uncured. We do that with a vulcanization tank. We submerge the whole mold, sealed up, into this tank, and the temperature creates a chemical reaction within the rubber, and it physically changes it from something that's more like rubber, as you would know it from like a car tire, but what goes into the mold is maybe something that's more like chewing gum, where it's very stretchy and doesn't have a whole lot of springiness to it. This is where the magic chemistry happens in the vulcanization tank. Just as it's important that we vulcanize it for a set period of time, we're also going to stop that from happening. So we have so much heat built up in thousands of pounds of steel and rubber that we have to remove that heat very effectively, very quickly. So this tank, called a quench tank, it's basically a cold water tank that is going to remove the heat from it so that it's safer to handle, also easier to break down, but mostly that it will stop that chemical reaction.
All the chemical processes are done now. It's time to remove the mold.
It requires a lot of force to extract this core because you have a very smooth surface that's dry, and you have rubber touching all of that surface for up to 25 feet. It's very important that we maintain concentricity between the part and the cylinder that we're pulling with. So we can only pull with the stroke of the cylinder, which is a set distance. So we ratchet back, and each one of these notches is a place that this trolley will then index against. So what you'll see is that it will go back a set distance. You'll hear a gate close, which will basically engage these areas, and then he'll pull again. And so he pulls little strokes, pushes it back, little stroke, and as he does that, more and more of the core comes out, and the tube travels down the rest of the machine body. As this comes out, we don't want the core to be unsupported. It's very important that it's very straight, because we have to have it completely centered within each tube. They're all different sizes. The only way to accommodate that is to have something that's soft that can come up and catch it. So this will actually come up and catch the core as it comes out. So it's always evenly supported. We take care of it because we put a lot of work, time, and money into creating these molds. And it's the only one in the world. It's custom built for us.
There's one last step in the stator building process before it's ready to ship.
This is the last physical operation before we inspect and ship. We always need to make sure that the rubber can be sent to our customer in a way that a rotor can be received within it. So what he's doing right now is what we call a cut back. So he's actually machining the rubber back a set distance, and when he's done, it will look like this.
ArcoTech also makes their own molds and rotors. We will show you how it's done in a future episode.